The HEADSTART, Harmonized European Solutions for Testing Automated Road Transport project, aims to define testing and validation procedures of connected and automated driving functions, including key technologies such as communications, cybersecurity, and positioning. The HEADSTART project brought together the consortium with other European and national CCAM stakeholders to cluster the most relevant existing initiatives, develop methodologies, procedures, and tools, and drive in a harmonized European solution for testing and validation of automated road vehicles. This way, it's been possible to harmonize past and present projects, utilizing common databases to analyze the data of international and national projects. This process led to the definition of a set of relevant testing scenarios that were the foundation of the project. These relevant testing scenarios were created using a very large selection of real-life data taken from different sources such as simulator studies, accident data, aerial data, and field data. The testing scenarios were then selected and processed, analyzing their feasibility. With all this preparation work done, the new test scenarios were created. These scenarios were then executed and evaluated in all available testing platforms and demonstrated in various projects. This also required the definition of a coordination criteria that would bring together the CCAM stakeholders and allow each user group to utilize their own testing environment, but with a common validation methodology. These procedures were divided in 4 main iterative test methods. The virtual testing methodology consisted in the setup of needed resources, setup of interfaces and plant models, as well as the setup of the metrics to define the KPI. With this preparation done, the tests were executed and monitored in the virtual environments, and all data was extracted and stored for its study and evaluation. ZIL testing was also carried out. In this, the preparation consisted in the validation of all components, the identification of the test cases, as well as the consideration of all KPI for the selection and definition of test parameters. The execution of these tests was far more complex than the virtual testing and therefore required more resources and time. Once these tests were executed, the relevant parameters for evaluation were extracted and used to compare them with the KPI requirements. Another test method evaluated consisted in real-life proving ground testing. For this, relevant test scenarios were evaluated and vehicles were put to test. These vehicles were tested against infrastructure equipment such as dummies, GNSS stations, and other moving vehicles. The execution of these proving ground tests was long and complex, as many more parameters were needed to be accounted for. All the data of these tests, as well as the results, were also stored and analyzed in order to extract the relevant parameters for evaluation and their comparison with all KPI requirement data. The 4th test method used included the vehicles and systems tested in the field. With all this, the HEADSTART project, through all the partners of the consortium, was able to define and unify methodologies and procedures on an international level in order to provide a safety assurance framework in which to accommodate all different national initiatives and thus create a harmonized European solution for testing automated vehicles.